In this video, I'd like to talk more about solving similar triangles that are a bit more advanced. And remember that similar triangles have the same shape but different sizes. And for this example problem, we need to figure out what this missing side length here is, this length CB, which we can call x. And what we can notice is that we have two different triangles. One triangle is within the bigger triangle. So we have this triangle ABC, and we have this triangle ADE. And we can prove that these two triangles are similar by noticing that they have three sets of equal angles. Since they share this angle here with vertex A, and we know they each have a 90-degree angle, and from this, since we know two of the angles, we can prove that they have the third angle in common. Since let's call this angle here y, and we can call this angle z, and we can figure out how z is related to y and this 90-degree angle. Since if we set up an equation, we have that y plus z plus the right angle, the 90-degree angle, is equal to 180 degrees, since all triangles add up to 180. So to solve for z, we can subtract 90 and subtract y, which means that z is 90 degrees minus y. Now, looking at the other triangle, if we call this some other letter, let's say that this is A, then we can set up an equation to figure out what A is, but what we'll notice is that A is also equal to 90 degrees minus y. Since if we sum them up, we can say that y plus A, plus 90 degrees, this is also equal to 180. And solving for A, we can subtract 90 and subtract y. We would find that A is 90 degrees minus y, but since z is also equal to that, that means that A and z are the same thing. So really we can say that this angle here is also z. And therefore, the two triangles are similar to each other. And we can write that triangle ABC is similar to triangle ADE, where notice that the order in which the letters are written describes the relationship between the sides. It tells us which sides are proportional, and it also tells us which angles are equal. Since notice that, for instance, angle ABC here, this right angle, this is equal to angle ADE, which notice is also the right angle right here. And to solve for x, since we now have proven that the two triangles are similar, we can set up a proportionality equation. Since we know that in similar triangles, the side lengths are proportional. Meaning that if we look at the ratio of, let's say, this side compared to this side, since they correspond to each other, that ratio will be equal to the ratio of, let's say, this side compared to this long side here, the side AB divided by AD. So let's set up that equation. We can say that the ratio of CB compared to ED, or we can look at it flipped over, it's reciprocal, is equal to the ratio of AB compared to AD in the bigger triangle. And remember that when we look at these ratios of corresponding sides, that they're always equal to the same number. And if we actually plug in some numbers here, we can do that down here. We have that CB, that is x, ED is 2, and this is equal to AB, which is 6, divided by AD, and notice AD is the sum of these two lengths here, and 6 plus 4 is 10. So the proportionality constant we can actually figure out by looking at AB compared to AD, which is 6 compared to 10, and if we simplify that, we can write this as x over 2 is 3/5, meaning that 3/5 is the proportionality constant, or we can again look at its reciprocal, which would be 5/3, meaning that to go from one of the sides in the smaller triangle to that corresponding side in the bigger triangle, we would multiply by 5/3. Or using its reciprocal by taking the bottom side in the big triangle, which is 10, and comparing it to its corresponding side in the smaller triangle, we would multiply by 3/5, or we would divide by 1.6, repeating, however you want to look at it. So from this equation, we can solve for x, and let's multiply each side by 2 so that we can get x by itself, since 2 divided by 2 is 1. And x would be 6 in the numerator and 5 in the denominator.